So what is a stack and what is queues? What are queues? A stack is a data structure that stores and retrieves data in a last in, first out. So stacks is a data structure that stores and retrieves items in a last in, first out manner. On the other hand, queues are data structures that store and retrieve items in a first in, first out manner. So this is called FIFO and this is called LIFO. Also could be called FILO because the same, it depends how you look at it. Last in, first out is the same as first in, last out. So let me open Paint. I don't know why my keyboard is not working. Paint 3D, new. Okay. So stacks are data structures that store and retrieve items in a last in, first out, or first in, last out. You can imagine it as having a cylinder like this that is open only from one side. You're gonna have slots. Of course, there are fixed size stacks, there are dynamic stacks. It depends how you implement it. And you have 4 important methods for a stack. You have push, you have pop, you have top, and you have empty, means is empty. So in a stack data structure, unlike arrays or vectors or maps or sets, unlike them, in a stack, you only have access to one item at a time, and you can only add one item at a time. So when you add an item, you're basically adding it from the open side of the container. And when you pop an item, you're popping it from the same open side of this item. So if I have this container or this data, 1, 3, 5, for example, 2, and then I perform or apply push on the one, let's do red. When I start with 1, it's gonna push 1 here. So now empty is false, it's not empty. And top gives you the item on top of this stack. It doesn't remove it from the stack. It just gives you a copy of the item on top of this stack. Pop removes item from the stack. Push, as mentioned, pushes or adds item to the stack. So when I push, let's say this is red. So when I push an item, it's gonna go on top of this stack. If I push another item, then this, how do I clear? How do I, here it is. So when I push another item, then the one will go down and then 3 comes on top. So now if I call top, I'm gonna get 3. If I call pop, then 3 will be removed from the stack. So notice how the LIFO behavior or the FILO behavior. The last item that went into the container would be the first item that goes out of the container. So again, if I push 5, now 1 and 3 will go down. So 1, 3. Now 5 will be on top. So if I call pop, the 5, which was the last item that added to the container, would go out of this container. Top will give me copy of 5. Empty will return false. Again, if I push 2, now all these items will go down, and I'm gonna have access only to the item on top of the container. So this is the behavior. If you notice in a Word document, for example, if I started a new Word document, or also in here, notice if I type, I want to show you like a real life example of a stack. There are a lot of real life examples. One of them is something that you use probably on daily on daily basis, and they could ask you in an interview question to like ask you about this functionality and how would you implement it. The way you implement it is using a stack. For example, notice when I'm typing here, 1, 2, 3, 4, 5. Imagine every time I add a character, I'm pushing to a stack. So push 1, push 2, push 3, push 4, push 5. Now if I want to undo, you see this icon, undo, or the Control Z functionality. What does Control Z do? Control Z or undo will undo the last action I did. So the last action I did would be the first action to be undone. So if I click Control Z, well, it's not gonna work in Visual Studio because it's gonna do the whole thing. So let's try 1, 2, 3, 4 with a space. So 5, no, it's gonna do the whole thing. Let's do, to give it a better presentation, let's do it on a Word document, because I think Word document does it one character at a time. So 1, 2, 3, 4, 5. Now if I want to undo, oh, it's taking the whole thing. So 1, 2, 3, 4, 5. So now, okay, so with enter, it's gonna do it one character at a time. So I pushed, I added to the document the character 1, the character 2, the character 3, the character 4, the character 5. If I do Control Z, the last item or the last action I did would be the first action to be undone. So Control Z, it popped 5 from the document. Control Z, it popped the new line from the character. Control Z, it popped the 4 from the container. So the first item that I pushed to the container would be the last item to be popped from the container. So this is where FILO and LIFO mean the same thing. First in, last out is the same as last in, first out. So this functionality uses a stack. Another example, if you want to understand stacks, imagine you are a dish cleaner in a restaurant. People are gonna, or clients are gonna, this is, let's say this is the sink, right? Something like this. And I have the counter. And this is the faucet. So if I'm working on the sink, washing dishes, clients are gonna come in line, and then they're gonna start putting the plates. First client, second client, third client. So notice with this behavior, I have a stack of plates, meaning the last client that puts the plate, his plate would be the first item that goes in the sink. So last item, first out, LIFO. Or first item, which is the very bottom, would be the last out. LIFO and FILO are the same. So the client that puts plates at the end would be the owner of the plate that goes first out from this stack of plates. So let's do some implementation now. Let's do coding. You can do your own class, or we can use STL class. So there are 4 important methods as mentioned. Include, I'm gonna include the stack. Stack is a template class provided by the language, by C++. That means, the fact that it's template, that means I can use it with any data type. I can use it with my own data type or with primitive data types from C++. The way to declare it, I'm going to say I would like a stack, for example, int my stack. Then I have a push method, pop method, top method, and empty method. These are the important methods for this container. Of course, since it's STL, standard template library, it has the 75% common functions with other containers like size and other ones. But these are specific to this container. So, for example, right now I'm going to say if my stack empty, cout stack is empty. Else cout stack has my stack dot size items. So I'm gonna use this if else statement multiple times throughout my code. I can move it to a function called void display info and takes a stack. A stack A stack. A stands for argument. L stands for local. So I have this function that I'm gonna use multiple times. Instead of duplicating 4 lines of code, I'm just gonna call this method multiple times. So display info my stack. Here we're gonna display some info. Then I'm gonna say, okay, my stack dot push 1. Then I'm gonna say my stack push 2. my stack dot push 3. Then I'm gonna display the info again before pop. Now that I displayed the info, I'm gonna say, okay, I would like you to display top is my stack dot top. Remember, top does not remove any items from the stack. It only displays the item at the top of the stack, a copy of that item. Meaning, if I grab this and assign it to a local variable and then change the local variable, nothing is going to happen to the container. This is not a reference of the top item. So this is the top. Now I'm going to pop an item. lMyStack dot pop. And notice pop doesn't take any input. It doesn't require any input. It's not like a vector or a map where you say, okay, erase item at index X or erase item that is equal to X. No, since in my stacks, since I have access only to one item at a time, then pop would remove that item. So now that I remove this item, I'm gonna say, okay, display some info. As a matter of fact, we're gonna remove this line and put it in display info. So stack has this, and it is this. So if it's not empty, then I would say it's not empty and display its top. Otherwise, if I attempt to pop from an empty container, then it's gonna crash. So now that I popped, I said, okay, display some info. And empty, we already covered it. So let's run my code now. And while running, I'm gonna display what we see. So I have a stack. Let's actually do it here. So I declared a stack. Here's my stack. Let's close this. Don't save. Let's close this. Don't save. Let's close this. Let's close this. Now we are good. So display some info. The stack is empty. Now I'm gonna push one. Now one is gonna come here and then sits on top. I'm gonna push two. Now that I push two, one is gonna move down and two will sit on top. Then I'm gonna push three. So same. Now one and two will move down and three is gonna sit on top. Display some info. So it's gonna tell me, okay, the stack has three items and the top is three. Here it is. Then I'm gonna say, okay, pop. Now popping, and notice again, I didn't tell it which item to pop because in stacks, I only have access to one item, which is the item on top. So now that I popped, that means three is gonna be popped and then two and one will move to top. So one will move back here and now two would be on top. So display some info. Now it's gonna tell me stack has two items and the top is two. Correct. Three is gone, removed from the container. So now my stack has two items and the top is two. So this is basically stacks, as simple as that. Now you can create your own class of stack and provide more info, maybe having access to specific item in a stack. For example, in this case, after I push three items, I can provide a method that says, okay, give me the item at index 0. In that case, what I need to do is, anytime someone says get, for example, the method is get, and it takes index. Let's say it's index 0. 0 means the first item, right? The first item that was added to the container. What I would need to do is I would need to pop many items up until size is equal 1. Once size is equal 1 means the value 1 is on top. Then I can return a copy of that value, but then I need to push the items that I removed back to the container in a specific order. In order to do that, when I pop items, I need to pop them to another stack. This way, I maintain the LIFO behavior. So I pop from the item, pop from the container 3, and then I push this 3 to a temporary container, another container. So now 3 is gonna sit in the container. Then I pop the 2. Once I pop the 2 from the main container, I push it to the temporary container. So now 1, I keep doing this until size becomes 1. Once size become 1, that means 1, the value is on top and the user is asking for index 0. Then I reserve a copy of this value. Once I reserve this value, then I need to pop back from here to my main container. So I pop from this container back and push it to this container. So now I have 1 back here and 2 here, and 2 will be gone. Then I do the same for 3 back to this container. Let's actually do it. So I'm gonna have a class called myStack. This class has a stack. I'm gonna do them all as public. This item has my class and it has an int, since I'm using int, or I can do it as template and say t. Then instead of int, I replace t, and instead of int, I replace t. So I'm gonna say get, and this takes an index, a index. So I'm gonna replace the STL with my stack. I'm gonna display some info. I'm gonna replace these. I'm gonna replace these. I'm gonna replace these. Okay, so now I have void push that takes an item and push it to myStack or mStack, which is the member variable stack. So mStack dot push a input. This is push, done. Then I have a pop. What does pop do? Returns nothing. Pop and takes nothing. mStack dot pop. Then I have size, which returns, let's return size t, which is an unsigned int under the hood. Size. This returns mStack dot size. Then I have empty, which returns a boolean. Empty, takes nothing, and return mStack equals mStack dot size equals 0. So if this is true, it's gonna return true. If this is false, if this operator evaluates to true, it's gonna return true. If this operator evaluates to false, imagine it between parentheses. So if this operation evaluates to true, it's going to return true. If this operation evaluates to false, it's going to return false. What else we're missing top. So now top returns what? The T, whatever the type is. In this case is int. Int top takes nothing and returns mstack dot top. So I didn't do anything. I just moved the main operations into my own class. Now I need to implement this get that we saw here. My driver program would be, this is my driver program, would be creating a stack, display some info, push some info, display, and then I'm gonna say get index equal 1, for example. C out and L. So let's implement this functionality because they might ask you about it in an interview. Implement a function that takes an index, or implement a function that uses mstack or stack and returns an item at specific index. Yes, you can return the item the way you want, but you still need to maintain the order for future operations. It's not like when someone calls this function once, you just destroy the stack, you pop, get the item, and that's it. No, you need to bring back all the items so that you maintain the code for future calls. So in get, as we mentioned, we need a temporary stack. So I'm going to say I need a stack called ltemp. Now, first things first. First, if mstack.empty, as a matter of fact, I can call my own method because this class has a method. If it's empty, then maybe return -1 or throw. That's not our concern, but I need to check first if it's empty. Otherwise, I don't even need the else statement because I'm returning in this case. Otherwise, prepare a temporary stack. Then I'm going to say while the current index, so int L index. So while L index is not equal to A index, while I didn't reach the target that I'm looking for. So while local index is not the input index, and this would be equals to the stack size. So size, right? If I have 3, then I'm gonna keep doing this until 3 becomes the targeted index. So if someone sends me 1, this is 3 in this example. So 1 and 3, while 3 is not 1. Every time I do an operation, I'm gonna decrease index. So first time it's 3, then it becomes 2, then it becomes 1. So I reached my index. However, if we wanna do just like computers do, which is 0 to whatever, instead of 1 for the first item, should be 0 for the first item. So L index would be size -1. The size is 3. That means this index, let's call it the starting index. Starting index, and this is the target index. So this becomes 2. So while 2 is not 1, do a task, then decrease it. Once the starting index in my functionality reaches the target index, then I'm gonna break out of the loop and do some other task or continue with my task. So while this is happening, and I will also call this target index. I'm gonna do whatever I displayed, I'm gonna get a copy of the top, then pop it, push it to a temporary stack, and repeat. Get a copy of the top, push it to the temporary container, and repeat. Let's make it a little more complicated just so we run the loop more than once. So 4, 5. I have 5 items and the user is asking to get the item at index 2, like halfway. Halfway to my, so the user is asking 2, and this has 5 items, which is 5 minus 1. So I'm gonna say, okay, reserve or current value equals my stack dot top. Now that I reserve the copy, I'm gonna say, hey stack, I need you to pop. Then I'm gonna say to the temp stack, push current value. Now that I did this task, which is removing from the main container to the temporary container, I'm gonna move forward. Starting index decreased. Then it's gonna check again. Once we go out of this loop, then I'm gonna create a result or the return value equals whatever my stack dot top is. Now that I reserved a copy to return, I'm gonna undo what I did, meaning bring back from the temporary container back to this container. I can do this operation using a slightly different condition. The condition would be, if I'm thinking about it, the condition would be while temporary stack is not empty. While I still have values in the temporary stack, do the task. So while temp stack dot empty equals false, while I still have items. Let's call it temp stack. So while temporary stack is not empty, I'm gonna do something similar to this. So I'm gonna grab it, copy. I'm gonna say current value is whatever temporary stack is, temporary stack pop, and then stack push. Now that I did this task, I'm gonna return return value. So let's run it. F10. Illegal use of void. Oh, we're missing. What are we missing? Oh, you see all these bunch of errors. Why? Because I'm using mstack at the top of the file, but mstack declared here. So I'm gonna do forward declaration, just like operation overloading. Remember operator overloading for insertion and extraction operations. So I'm gonna say class my stack. I can do it this way, or I can move this function to the bottom of the class. So now display info is at the bottom of the class and out of main. I mean top of main. So when main uses display info, it knows about it. And when display info knows about my stack, it also knows about it. So I can now remove this and run again. So display info. Why didn't display info? Oh, I have a different screen. Run again. Is stack empty? Yes. See out, stack is empty. Here it is. So now push 1, 2, 3, 4, 5. If I hover my mouse, I'm gonna see that I have the member stack size 5. If I open it, it's gonna show 1, 2, 3, 4, 5. This is index 0, this is index 4. Display info again, has 5 items, top is 5. So now get index of 2. Here it is. Am I empty? No. Okay, I need a temporary stack, and the starting index is 4. The top index is 4. Again, we saw it earlier. So see, here's the top index 4. So while starting index is not the target index, is this true? No. Okay, so top, give me the value 5, pop it from the main container. So now size is 5. Push it to the temporary container. So now it's size 1. Then starting index become 3. So notice starting index became 3. So now the top is at 3. I did not reach the target yet. Did I? No. Move on. Now, did I? Yes, it is. Now that I reached the target, notice that mstack has this as top, and temporary stack has the 4 and 5 in them in a specific order. 4 is on top of the stack, 5 is at the bottom of the stack. Just like we saw earlier here. 3, then 2. So return value, reserve it. This is the item at index equal 2. It's the value 3. Then I need to bring back the container the same way it was when I first started this method. So go, done. Temporary stack is empty. mstack is back the way it was. 1, 2, 3, 4, 5. Return. So now display top is 5, and at index 2, the value is 3. That's pretty much it for stack. There is only one more, there's also one more challenge for stacks, which is implementing stack using queue or implementing a queue using a stack. It's frequently asked in interview. So let's explain how queues work. Then we can show you how to implement a stack using queue or the opposite. I'm not gonna show you how to get using a queue because I already showed it, so you can do it on your own for queues. So now for queues. Queues can be looked at as a pipe. In a pipe situation, you have the FIFO behavior. FIFO means first in, first out. So yeah, if I have this data 1, 3, 5, 2, and I have four main methods. One is push, just like stacks. One is pop, just like stacks. One is front instead of top, and empty. So this is the only difference between stack and the queues. Alongside these methods for queues, you have the other ones that are common with STL containers. So if I start here, let's say with green, if I push, then 1 is gonna sit here. Since the queue has only one item, then this would be the front. If I call front, I'm gonna get a copy of 1. Or you can imagine it, for example, when you push 1 and it sits here. Then you push 3. So 3 is gonna sit here. Then you push 5, then 5 sits here. Then you push 2, then 2 sits here. Anytime you call front, you're gonna receive you're gonna receive, for example, this is or front. If I call front, then I'm gonna receive the 1. If I call pop, then pop will be removing 1 from the queue. Whatever the item that was first in. So the first in is the first out. So let's do example for these 4. I'm gonna comment or not comment, just remove them. And same to stack. If I need to use a queue, I need to include it queue. Same way. L my queue dot push. I'm gonna push 1. Then I'm gonna push 3, 5, 2. So 3, 5, 2. I'm gonna display info. My queue is gonna say I don't have a version for that. So I'm gonna say, hey, you grab a queue of n. So I'm overloading this method. It doesn't have a top. A my queue empty has it, size has it. It doesn't have top, it has a front. So now that I did this, I'm gonna say, okay, I'll see out the top. L my queue top is or front is, sorry. Then I'm gonna pop. And then I'm gonna say front again. Run. So I declared my queue and then I pushed 5. Display info stack tag. So it has 4 items now. I had well, this is 4. Oh yeah, I didn't pop anything. So it has 4 items and the front is, let's fix it. Queue is empty. Queue is front is. Run again. So queue has 4 items. At this point, when display info was called, front is 1. Why? Because it was the first item in. So the first item in would be the one ready to be popped or sitting in front. Again, front is, here is front. Then I'm popping. So now I have the front in this line 107. The front became 3 because 1 has been popped. So this is the opposite of stack. Instead of popping the last item that went in, which is 2, it popped the first item that went in, which is 1. Now I can do the same like this. So I'm gonna call this my queue. And I'm gonna say this uses queue. Now queue, let's wait for on the get. Let's resolve these. So this push is the same, pop is the same, size is the same, empty is the same. Instead of top, I have front. And in front, I have front. Now with get, it would be there are several ways I can do it. Let's say I have this one. So I have this pushed as this is my container. Then someone asks, okay, I need the index, for example, 2. The index 2 in this example is, if this is 0, then this is 1, then this is 2, then this is 3. Index 2 in this example is this. What I can do is I can do 4 times. I can do something 4 times. Why 4 times? Because this is the size of my queue. What I can do is I can pop from here back to here. I can do this 4 times. If I do this 4 times, I'm going to end up with the same container. The same container I started with, or the same order I started with. If I pop, then push, pop, then push, pop, then push, pop, then push 4 times, meaning the size of my queue, I'm going to end up with the same order. So I can follow this approach. I can say, okay, let me pop and push 4 times, but keep track on which index I'm on. First, I'm on index 0. When I do it the first time, meaning push, pop, then push, then I'm gonna become at index 1. When I pop and push again, then I'm gonna become at index 2. This is my target. Reserve a copy, then continue, pop, push until the size of my queue, and I'm gonna finish my task. I'm gonna have the reserved value at the target index, and I'm gonna end up with the same structure. I can do it this way, or I can do it the other way, which is popping to a container, reserving maintaining the order. Once I reach the target of my um, function, basically, the task I'm trying to do, then I can continue popping everything into a container. Once I pop all this, then I can start, actually, it needs to be another a queue. So pop 1 to my queue. So 1 is gonna sit here, then 3, then 5, then 2. Once I'm done, then I need to pop back to the main container. So pop 1 goes sits here, pop 3, 3 goes sits here, 5, 2. But the first approach is better. Why? Because we are not using extra memory in the first approach. So let's do the first approach for get. My stack is not here anymore. We don't need it anymore. Okay, so get. I'm gonna keep this. I'm gonna remove these. I'm gonna say prepare int l return value. So if it's empty, return value is -1. Return l value. Return. Otherwise, I'm gonna say while or for loop int I equal, because I want to iterate up is equal to the size. For the first approach, the first approach was this: pop push to the same container number of times equal to the size of the container, whatever the size of my container. If it's 10, then do it 10 times. If it's 5, then do it 5 times. So I need a for loop because I need a counter controlled loop, not a Boolean controlled loop like while. While takes a Boolean, while true or false. I can add a counter to it, but for loop provides a better like readability for the code, and it has a counter in it. So for int I equals 0, I less than my q, mq, sorry. Did I call it mq or my q? Oh, I'm stack. Mq. So everywhere that I have m stack, I need to replace it with mq. So now mq dot size, or actually the size, I have it already. I plus plus. So I know for sure that I need to uh, pop and push to my container. So L, I'm gonna say L popped value equal L MQ, or actually I have it. I have a function called front. So this is the popped value. I know for sure that I need on this loop, the first thing I need to do is popping from my container. And the last thing I need to do is pushing back to my container. So MQ push L popped value. I know for sure that these two needs to be done. However, in between, I need to keep a track. If L current index equals to a target index. If this is the case, then L return value equals to the popped value. So what is current index? Current index is equal to I, because I starts from 0, right? This is 0, 1, 2, 3. So I can take this as I. So I can use I, or I can call I current index. This is pretty much it. L return value is returned. What is saying? Using uninitialized memory return value. Okay, so L return value equals empty. If it's empty, -1. Otherwise, I'm gonna say mq.top. I mean front. I don't need this anymore. So now I got rid of the warning. So let's try it. I think it's gonna work. So I have these indexes, display info, front, don't pop. Let's say cout get at 2. Maybe it needs me to recompile. Okay, stop. Class this and that has no number get. Oh, I didn't create my class. I created the STL class. So my queue. Display info. We don't want to display info for now. Front is get front is. So this front, we're gonna use it as a test to make sure that the order of the values before the function call is the same after the function call. So run 1352. So I have this structure 1352. Front is 1, correct. Then get return value. Since it's not empty, it's gonna be front for now. Then from this up to this, actually this is correct, because if size is only 1, then this will never execute. So whatever index they send me, I'm gonna send them only 1. Actually, if I wanna perfect it, I need to check that the input index, just like in operator overloading, anytime someone uses indexing, I need to make sure that it is within the range. It is not negative and it's not above size -1. So for now, I'm gonna say the popped value is 1. Okay, am I in the right target? No. Okay, then push it back to the queue. So now queue is, oh, why 5? Oh, I need to pop. I forgot to pop it. So I pushed it. Here I grabbed front, but I need to pop it. So pop. Start over. And pop. Yeah, I have a pop. Oh, pop is void, sorry. So here I'm gonna say mq dot pop. I forgot to pop it. So try again. Oh, I forgot. So front, this is the popped value. Now my Q is, instead of 1352, it is 3521. So one left from the front of the queue back to the back of the queue. Am I on the targeted? Excuse me. Am I in the targeted index? No, not yet. Okay, continue. Am I on the target index? Yes. Okay. The return value is 5. Then continue to maintain the order. Now my queue has the order that we started with, M352, and the return value is 5, which is the one that was at index 2. Here it is. So continue. The order is the same and the result is correct. Excuse me. Okay, with that being said, I'm gonna just do one more thing, which is a frequent or popular question that says, design a stack, for example. I need a class that provides a stack behavior, but under the hood, it uses a queue. Or another way is, design a class that provides a queue behavior, just like now, but under the hood, it uses a stack instead of queue. So this class, which is my interface, I designed this class, so I'm providing an interface to whoever uses it. For example, here, this class provides an interface of a queue. It has a push, it has a front, it has empty, it has pop, it also has get. So the interface or the behavior of this class is a queue behavior, meaning FIFO. First item that gets in is the first item that gets out. So provide a class that behaves as a queue, but under the hood, it uses a stack. This changes a lot of things. This changes get, this changes the way you push, the way you pop, etc. Why? Because, let's delete this. Because if I want to provide the behavior of a queue, but I have a stack, then look at this. Under the hood, I have a stack. Stack has only one end. So I go back. What is my container? 1, 3, 5, 2. If I push all these, then 1, 3, 5, 2 are gonna sit in this order. So when someone uses my class, pushes this item, thinking it's a queue, or it's required to be used as a queue. When they push this item and then they call pop, popping should not pop 2, should pop 1, because the class behaves as a queue. Yes, under the hood it uses a stack, but the pop method should maintain a specific task. So what I need to do is, I need another temporary stack. Anytime the user calls pop, I need to remove all the items except the last one. and push them in a stack. That means pop from here, pop from here, pop from here. Now that I reached the last item, reserve it as the return value. Reserve. Now that I reserved it in order to be returned, I need to bring back these items. So let's use value. Pop from here, pop, pop. The empty is the same. Empty works same for both containers. And then instead of I will expose a pop method from my class because it's an interface of Q, but under the hood, the pop, the front should be a pop, and the popping needs this kind of structure. For pushing, it's fine. Anytime a user push, I will just push to the stack. But anytime a user pops, I'm gonna have to do this task. So, and we'll also have to resolve a get. But get is pretty much easy. So push is the same as we agreed. Size is the same, empty is the same. Front should be pop. So let's remove this because we don't need pop in my queue. Now front, as mentioned, first, if empty, return -1. Or I'm going to say int L return value equal empty. If it's empty, -1, else it is, oh, I have to do that behavior. So let's do this. -1. If empty, I'll return value, oh, without the need, just go and say, while size is not equal to 1, just like we painted it. Anytime you need to solve a problem, open a scratch, open a paper, or put a paper or a pen, or open your favorite art platform. Think about the problem, draw it. Just like this is very helpful. Thinking of the problem for a while will help you solve the problem. Don't just open the code and start coding and figuring things out while you're coding, because you're gonna waste a lot of time. If you draw it and do the thinking ahead of time, then implementing it would be easy because you already figured out things. You're only implementing it. You're only doing the task. Okay, this is first, this is second, this is third. You already figured things out. So while size is not 1, I need a temporary stack. I need stack of int L temp stack. Now I need to say, okay, int L popped value equals to mstack. It's called still mq. mstack dot pop. I mean top. Then L temp stack dot push L pop value. Then I need to pop it mstack dot pop, because I need to trigger size to change. What is my changing statement? Changing statement is this. So this at some point will break me out of the loop. This statement will break me out of the loop. Now, once size is equal to 1, then return value is mstack.top. Now that I reserved this, I need to bring back the values from the temporary stack to the main stack. And I can do this by saying while temp stack is not empty. So while it's not empty, I need to do something like this. However, the opposite. So L pop value is whatever L temp stack top, then M stack push the popped value, then pop it from the stack. And finally, return I'll return value. And forget, since it's a stack, I need to do the same method that I did earlier for stack. So you have that. So I'm gonna just comment this out. And push this ready, empty is ready, front is ready. So let's try it. It uses queue under the hood, but it uses stack under the hood, but I'm gonna show queue behavior. Here I'm gonna say L my queue dot pop. Pop. How did I remove it? Where is pop? Why did we lost pop? So front should be similar to pop, but pop doesn't return anything. So void pop is same. I have a stack, L return value, int L. Oh, I don't need a return value. I just need to pop it, remove it. Pop, bring it back. This is it, right? Front and pop are the same. The only difference is front returns the value, pop doesn't return the value. So here, when I said reserve the value so I can return it in front, in pop, I don't need to reserve that value, just pop it to remove it from the stack. Yeah, this is it. I'm gonna remove these comments. This is called mstack. Size is called mstack. Empty is called mstack. Front is ready, pop is ready. So what is, show me what's front, pop, show me what's front, pop again. Show me what's front, push a couple times. Let's push 8, 9. Show me what's front. So let's try it. So pushing 1352 to my queue. Here's my queue. I know that under the hood it uses stack, but I'm testing the interface now. I don't care about under the hood. So this is my queue, and I just pushed 1, 3, 5, 2. I'm testing. So front, what is front? Front should be 1. Is it 1? Correct. Cool. Then pop. When I pop, then I lost 1. Now this is my queue. Front should be 3. Here it is, 3. Cool. Then pop. When I pop, then I'm done with the 3. So front should be 5. Front should be 5. 5, here it is. Then I'm pushing 8, 9. So when I push 8, 9, 8 will go sit here, 9 will go sit here. So front is still 5. Let's see. Come on. Here it is, 5. Nice. So it worked. And that's pretty much it. These are the most important topics in queues and stacks. There is an important topic for having a dynamic memory allocation, which is basically when you push, you call the new operator, and when you pop, you call the delete operator. And under the hood, you can use an array or another stack or another queue, whatever you want under the hood. Whatever data structure you feel is better for the performance or better for the readability of the code. Anyhow, you have an interface and then you have back-end code. You have front end and back end. And then you have a driver program. Driver program would be a testing program that demonstrates if someone creates your class and uses it. That would be a driver program to the usage of your class. So that's it for this topic. I'm gonna post the homework, which is due the end of the semester. Next week is the final. So this is, I forgot to mention, this is the last week. We only have one more session, which is recursion. I'm gonna post it either tonight or tomorrow. And then we're gonna do one quick review session for everything we did throughout the semester and what's important in the final. And then we're gonna post the final exam and you should be good to go. So have a good day.